So let's pivot to other places where these search for ingredients of life have been in the news, such as Mars. Right, we're not quite there yet with Europa. We've got a nice Clipper mission en route. We have a whole episode of StarTalk where we toured the Jet Propulsion Labs and spoke to the folks. It was right around the launch time of the Europa Clipper mission to look for life with ice penetrating radar to look under the ice, that icy moon with its ocean of liquid water. But if we go to Mars, where there's no water today, but such ample evidence that there was once running water, do you compare notes with your fellow Mars geologists or Marsologists, whatever the word is you might call them, to see? Because I remember there's a recent news where there were some inclusions in some kind of clay or something that people felt pretty sure is a record of some kind of microbial life thriving in a distant past. And they're inclusions that only a geologist would recognize as being something interesting. And then you pair that up with the biologists, and all the astronomer can do is just watch you guys have a conversation about it.
Well, you can talk to us about it as you do. yeah. But that's a great. I like the way you drew that. That's so from lessons learned from analyzing Bennu, for example, and Ryugu, and there's several more papers coming out in the near future from the OSIRIS-REx mission that are going to detail even more interesting results about prebiotic compounds. So keep to the literature for that. Look for that very soon.
And just to be clear for everyone in this modern era, it means a research paper with many collaborators that has been submitted for peer review, has been revised according to whatever the peer review might have recommended. Then it shows up in the journal, online or otherwise. And that then gets disseminated around the world for others to comment on, to stand on the shoulders of what was there. That's what's going on here. He's not making a YouTube video.
Well, yeah, it's either that or he goes on Joe Rogan for 2 hours. It's either the first or Rogan for 2 hours, which is the same, by the way.
So on that area of Mars, what was it called? I forgot. Shiana Falls, is that what it was? Yeah. The minerals that were there in large veins of what are probably a mineral called gypsum and associated minerals are minerals that form through a fluid. Precipitation, they're evaporite minerals. They have to come out of this fluid that is there, and the fluid's evaporating. And other minerals that are there, such as vivianite, which is a phosphate mineral. Here we go, phosphorus again, one of the key ingredients for life.
Isn't gypsum on the Mohs scale? I have some memory of that.
You got that right.
So I got that right?
You got that right.
Gypsum is very soft. It's like one or two. Or
it's a hydrated mineral, so it has water attached to it, which makes it structure.
And then grigite is another mineral that form, and that's an iron sulfur-rich mineral. But that is an interesting mineral because it's on a pathway. The final product forming would be pyrite, which everybody knows as school scope. The mineral before that is mackinallite, big name, but that mineral was recently discovered in both Ryugu and Bennu for the first time. Now, why is this mineral grigite important? Because it's sampling different abundances of oxygen that is around in order to produce itself.
Okay. Now, oxygen is not uncommon in the universe, but it's highly reactive, right? So it's going to be binding with almost everything. And so where's it getting its oxygen from? What's its source?
Oh, that's a great question. We assume it's coming from a fluid interaction, a fluid that has evolved. But how that fluid's evolving, I don't know. When that fluid evolved, I don't know. And the landscape certainly is such that fluid was moving around, water.
In the Cheva Falls, in those deposits, I don't know, is that the right word? Inclusions,
yeah.
Those, yeah.
The sedimentary rock deposits.
Yeah. Are you convinced that there was an active biota in the distant past from that evidence? Or is there another way to explain that does not involve life? Because life would be extraordinary and fun, but you geologists have all kinds of ways you can make stuff, even without life.
Oh, I know it. Yeah. So I'm not sure if life was actually part of that process, but I'm not going to eliminate it as a scientist from that process. It could be what we call abiotic or not requiring life, but it may be that life was there. There are other evidence to suggest that, and I don't know the details of the organic compounds. There's simple organic compounds that were also found there that may indicate that life was there. But as we know from working with Bennu, we're beginning to understand that the organic compounds that we're finding in Bennu are much greater than what we see in the meteorites, and the process which formed them most likely it occurred inside of a great parent body or on surface or subsurface of Mars, for example, or Earth, and that is an important punctuation point that we have to know. Meteorites are definitely contaminated, so we're learning a lot about organic chemistry in the solar system, in the prebiotic chemistry from the meteorites. From the asteroid samples, that the meteorites are definitely contaminated.